Welcome everyone. My name is Daniel Nichols. I'm the Federal Program Manager for the Advanced Sensors and Instrumentation Program through the Office of Nuclear Energy at the U.S. Department of Energy. My counterpart, Patrick Calderoni, is the National Technical Director for this program. So today I'll be presenting on one of our calls as part of this year's FY22 calls. So giving a little bit of background context to the ASI program, our mission and our vision. So our mission first is to develop advanced sensors and INC that address critical technology gaps for monitoring, controlling existing and advanced reactors, and supporting fuel cycle development, and that also includes material development. And then our vision for NEAT ASI research results in advanced sensors and INC technologies that are specifically qualified, validated, and ready to be adopted by the nuclear industry. And so you can see those three area points on the bottom of the slide. So the goals of this program is mainly to support the DOE NE R&D programmatic needs. So ASI technology has provided valuable support for both fuels and material studies and have been included in integral testing. And this program has provided new capabilities for measuring, controlling, or measurement controls and operations. And these sensors specifically target harsh environment applications, advanced control capabilities, the pursuit of semi-autonomous and autonomous operations in the future, fault-tolerant operations, and then predictive analysis. And I'll go over that a little bit more in detail in the next slide. And then the goals also for this project is to address R&D needs for successful deployment. This includes digital technology and instrument qualification as part of our program. So our four strategic R&D areas, you'll hear these called out quite a bit, is of course the core is sensors and instrumentation. That's the fundamental aspect of our program, as well as communications methods, big data, machine learning, artificial intelligence, and advanced control systems. Each of these play a very integral portion of our program supporting the DOE mission. And all of these are focuses for our call for this year. We want an integrated approach that combines all of these aspects. That would be the most desirable proposals that we will see. So launching into the call, first thing I want to address is that in previous years, our calls through ASI have been targeted to include industry, national labs, and universities, but for this year, FY22, it will be only eligible for universities this year. And this call will be for up to 3 years and up to $800,000. So this is CT-5. So the challenge for our call is that the ASI program is searching for proposals related to structural health monitoring of advanced reactors, and definitions for these advanced reactors can be found in Appendix A.2.2 of the call report. This proposal, what we want to see in this proposals for this is an adequate level of knowledge and understanding of the target application, specifically the environment of the reactor that this sensor is proposed for. But talking about the objectives, these sensors, we would like to see sensors that are applicable not to just one reactor type, but multiple reactor concepts. So kind of a broad applicability. But as part of these proposals, we want to see a adequate understanding of all the different environments that the sensor can be applicable for. And then these sensors can, or the proposals for these sensors can target one or more plant systems and components, including the reactor core, the reactor vessel, and other in-vessel components, primary and secondary cooling circuits, in order to define the range of expected operation conditions. And this includes temperature, pressure, radiation field, and limitations in terms of material compatibility for more caustic environments, reactor environments. And in this application, again, the proposal should clearly outline the targeted operating conditions the range and the criteria to be used for proposed technology feasibility. This technology impact should be discussed in relation to its benefits in terms of reducing the operating and maintenance costs, or to increase the functionality and efficiency of a reactor design. The outcome of the proposed work should be the feasibility demonstration of a completed measurement system. This includes and is not limited to the sensing element, the hardware supporting that sensing element, and software used to interrogate the signal coming off the sensor, and then a data acquisition system and data analytics. This again kind of plays back into the 4 areas, R&D areas for our program, and how we want to support each of those areas. And the use of the technologies leading to high data throughput and the integration of advanced tools for data analytics compatibility with integration in real-time control systems is highly encouraged. That's something that we typically try to target, is real-time applications. So finally, to follow up, again, my name is Daniel Nichols, the Federal Program Manager. Also listed here is Patrick Calderoni, the technical lead for this call, and also the National Technical Director for the ASI program. I've also included a QR code to the Office of Nuclear Energy, specifically the ASI website. There you can gather more information, our newsletters, some project summaries from past projects that have been completed under our program. It's a good place to start if you're new to this program. So again, I appreciate your time, and ready to field any questions that you may have.
Thank you, Daniel. We do have a couple questions coming in. The first question is, would process measurements such as flow be of interest under the structural health monitoring umbrella?
Okay, I'm actually going to toss that question to Patrick Calderoni for a little bit more detail into that. Would you mind unmuting Patrick Calderoni?
Yeah, this is Patrick. Answer that question. I would say only if they can be successfully synced or successfully referred back to a method that entails structural health monitoring. In other words, flow could be a measurement for structural health monitoring, but not in terms of just developing the sensor itself. So measuring flow is not the target of this of the call this year. So if an instrument that measure flow is necessary as part of the narrative to develop a measurement system for structural health monitoring, that's possible. But again, it needs to be a complete package, and the target needs to be structural health monitoring, including how that then refers back to, as Dan mentioned, advantages in terms of easier maintenance, predictive maintenance, or efficiencies saving in terms of the system. So I don't know if that answered the question, but if it's just the flow meter or a new technology to measure flow, that's not part of the scope. If it's a flow meter that is part of the measurement system related to health monitoring, then yes.
Thank you, Patrick. The next question we have is, would the development of innovative neutron sensors for power monitoring be a consideration or be of interest in CT-5?
So I can start to answer that, and then if Patrick or Melissa want to chime in. So it kind of relates to the previous question. If that's in support of structural health monitoring, then correct. If it's just a standalone neutron detector, then that wouldn't really fulfill the call for this year. Patrick, do you have anything else to add?
No, I think that's appropriate. As far as flow is concerned, I could see possibly some connection, it being a piece. As far as the power monitoring itself, the way that I understand the question, I guess the answer there is more definitely no, in terms that we really wanted this year to have the call focused on one specific piece. The structural health monitoring is, of course, a giant area, and so there's enough scope there to justify having it as a scope of this call. Of course, power controls and neutron flux sensors are of interest to CT-5, but again, not of interest to the scope of the call this year.
Okay, thank you again. Does this work scope include sensors and instrumentation meant to monitor reactors for anti-proliferation or security purposes, or is it focused exclusively on reactor health?
I guess, Patrick, you mind if I throw that to you?
This is Melissa. I can also jump in if that works.
Sure.
Can you guys hear me?
Mm.
Okay, yeah, so I would say that the sensors for proliferation or security related endeavors, you would probably find a different scope area where that is more pertinent to under the cybersecurity program. I don't recall off the top of my mind what the number is for that specific scope area, but it should be close to this one. The sensors under the scope need to be for reactor performance.
Thank you, Melissa. The next question. Is it intended that the final feasibility demonstration occur at a reactor facility?
I can take that, and then no. So the way that we intend feasibility demonstration within a technology readiness level scale here is it reflects the technology readiness scale. So feasibility means the early stage of development. So we don't need a demonstration in relevant operating conditions. So to answer the question straight, no, it doesn't have to be demonstrated in a reactor. Feasibility means still laboratory testing. As part of the ASI program, there will be then different mechanisms which will take that technology to maturation through demonstration in a reactor.
Okay, thank you. Do you have any examples of current sensors that are being implemented?
Implemented in the fuel cycles or in material testing? Is that the question? I guess I'm asking for clarification.
Yeah, that's not specified. We can come back to that if the asker can provide a little.
I can probably provide at least, I think what the question is trying to address, whether there's technologies that we are already working on that could be applied to structural health monitoring. And I'll just, again, providing examples in this context is always dangerous. So I'll put all the disclaimers out. That doesn't mean that this is what we're looking after, but there are two specific general categories, broad categories of technology that we're looking to apply for health monitoring. One of them is using optical fibers, and the other one is using acoustic sensing. So that's just to provide a general context. Now, these are used in industries outside of nuclear to do the same function. So it's not something that I'm inventing, but it's something that we are working on. Again, no exclusivity there. Anything else would work, just two examples.
Wonderful. Can you define structural health monitoring for the purposes of this call?
Sure. So Patrick, I think you have a more specific, detailed definition for this. You mind tackling this?
Yeah, actually, I don't know that I mean, I guess I could go and look at a textbook to to provide a definition. So I'll just so structural health monitoring, what we mean here is a measurement system, and as Dan recalled in the back, so we're looking for at the end of his last slide, where we are targeting systems that can provide real-time information on the health of components, and that's to aid maintenance schemes like early fault detection, understanding things that are deteriorating in the performance of a reactor, so that it can be preventive maintenance schemes and strategies can be applied. So that's it's not a very accurate definition nor a broad one, but I think that's enough for understanding what we're discussing here.
Hey, thank you, Patrick. Next question. Would consideration be given to the monitoring of pumps and other power equipment such as vibration or spent fuel containers?
So I think with the pumps, that would I believe that would apply to the scope that we have defined here. We discussed how it relates to the primary or the secondary cooling loops. As for the spent fuel containers, I guess I would want to understand a little bit more what the person asking the question is targeting there. But that doesn't immediately bring to mind any applicability for this scope specifically. But I guess Patrick, would you like to comment as well?
No, I think you're right. There, as Melissa mentioned before, for the cybersecurity portion, there's a large area, many different sections of these calls that are dedicated to fuel cask and spent fuel. And so that's an area that basically is dealt with elsewhere. So if that application is specific to fuel cask, then the answer is no. While I echo your what you said on pumps, that is part of the scope.
Mm.
Okay, thank you both. The next question. Would a system that measures the shape of the reactor power profile for detection of flux tilts or hot channels fall within this scope?
So kind of working through it a little bit, I'm not exactly sure how that would apply to the health of the reactor, to the components, and potentially detecting failure mechanisms. I guess again, I would ask Patrick, do you have any comment on that? Or Melissa?
I think it's basically the same question as before.
Earlier.
It remains the same. So I think the answer is not.
Thank you. The next question. Are sensing approaches that monitor the temperature of structure internals of interest to this call?
I think it could be applicable, especially if there's like significant temperature gradients that may cause thermal fatigue or failure of components. I think that could apply to this call. Any other comments, or I guess Melissa or Patrick?
I agree. I think again, it needs to be stressed that that shouldn't be a measurement of temperature on its own. So this is a package measurement system, and you would need to demonstrate in the proposal how that measurement then refers back to, again, improvement either in maintenance or in efficiencies in terms of preventing failures and so forth. So really the focus should be the health monitoring part. There needs to be a connection on how temperature measurement are used towards that objective. But it does make sense to measure temperature for that.
Okay. The next question. Could a digital twin be recommended for demonstration?
I guess we hadn't considered that or discussed it previously. I would ask for a little bit more clarification from the person who submitted the question. What exactly do they mean by digital twin used for feasibility? Matter if we come back to that question after clarifications come in?
Yeah, if we get a clarification, we'll circle back to that question.
Appreciate it.
The next one says, it almost sounds like this call focuses on the health of infrastructure of SSCs as opposed to structural or civil structure health. Did I understand this correctly?
Patrick, do you mind tackling that as well?
I think I don't understand the question. Sorry.
Maybe we're in the same boat.
This is components. I don't know. I mean, I can provide examples that we're targeting reactor components. It could be health of fuel pins, could be health of pump blades, could be health of the vessel itself. So I'm not sure I understand it. I don't think it has anything to do with infrastructure. We're talking about basically reactor components or primary circuit components, secondary circuit components, heat exchangers, and so forth. normally the term infrastructure is used differently. So again, I don't know if I answered the question, but if I didn't, it's because I'm not fully understanding the context.
Okay, thank you for your answer. The next question is asking if this call aims to monitor components like pumps, valves, or structure like piping and tanks. And that might be quite similar to that last question.
Okay, maybe then I understand better the last question and both. So either and any of those. Any is the right question. Sorry, among the choice.
Those would be applicable to the scope.
Yeah, all are applicable.
Wonderful. Is the scope of this call open for real-time gamma and or neutron sensors inside spent fuel storage?
I guess we already answered that then. So
yeah, I would go back to an answer earlier, that those spent fuel systems are typically targeted under other scopes.
Okay. The next question might be a clarification to a previous question, but with regarding structures, do you consider that to be containment too?
I believe that would also play a role. So containment as in the concrete or the steel vessel, the primary vessel? I guess that would be another question. But so looking at the effect on the reactor, so for containment, I would assume if it plays a role into failure mechanisms for the reactor vessel, then I would consider that as part of the scope. I guess, Patrick, you mind chiming in?
Says yes.
Yeah.
Okay, and it looks like we have a couple more. Do the developed techniques need to work in situ, for example, while the reactor is running, or are ex situ monitoring techniques acceptable as well?
Well, yeah, that actually would play into defining the range of operability in the proposals. We discussed that for proposals for the scope, defining what environment those sensors will operate in is necessary for the proposal. So if someone was applying for or with a sensor idea that would operate only X core and when the reactor is offline, then that would need to be included in the proposal. But I think both are applicable to this call. We tend to lean more towards in situ online, but that's not necessarily a limitation.
Thank you. We have one last question that came in, and that reads, to demonstrate the effectiveness of an instrument implemented to measure, for example, a temperature across a pump during operation, then instead of placing the temperature in situ at a reactor, could it be utilized in a digital twin to demonstrate the ability to model the temperature profile during varied operations as modeled by the digital twin?
Okay, now, so this is a clarification to an earlier question. Patrick, do you mind tackling this one as well?
I think the consideration or the use or the demonstration through a digital twin, it could be part of the proposal. Again, the proposal stresses that the whole package needs to be demonstrated in terms of feasibility. So we would want to see hardware as well. So, but there's no reason why the demonstration portion or when we discuss how that applies then to either maintenance schemes or to efficiency gains in the reactor operation, that can be demonstrated through a digital twin. Yes, because we do not require here the demonstration of the hardware in relevant conditions such as a reactor. So I think to answer the question is yes, the digital twin is an appropriate portion of what the proposal could be. Although again, it needs to be stressed that the hardware is also an important portion. So there has to be the hardware portion of what the sensing element and what the sensor is, the interrogation and so forth.
Thank you. I'm glad we got a clarification for that earlier question. We have another question that came in. That is, would real-time detection of gamma fluxes at many locations within an operating reactor core fall under this scope? Possible health applications would be power measurement, ensuring that fuel assembly power and burnup is as the models predicted, detecting coolant channel blockage, other anomalies that change power, such as damaged or incorrectly located control rod.
Would that be applicable to the scope? Okay. It might be. It does kind of harken back to a question earlier where someone was asking about power peaking profiles. So we're specifically targeting measuring certain components and their failure mechanisms. I can see how that could tie in, but I guess, Patrick, do you have a comment or do you want to weigh in at all?
Well, I think this is basically, a continued clarification on the same question. So I think the way that this clarification is going, yeah, that my no answer may be refined a little bit. So if there is a clear tie to a power measurement, then referring back to health of, in this case, right, there would be a fuel assembly. I would say at this point, the way that this has been clarified shouldn't be discarded a priori. So a proposal would have to be considered.
Yep.
Could be considered, let's say. Again, stressing the fact that it has to be tied back to how it's applied for health monitoring rather than power control or power measurement, flux measurement.
Okay, thank you for those answers. And that completes the questions. And we are at about the end of the session as well. Thank you, Daniel, Patrick, and Melissa.